the next group. I'm your host today. I'm very glad to join me. Now, right now in our Shanghai branch. Our Shanghai factory mainly focuses on the development, design, and manufacturing of intelligent equipment, especially inspection machines for fasteners, bolts, nuts, screws, for fasteners. Our machines can inspect the quality of the parts. That is the features feature of our machine. Okay, welcome to our live stream. Right now I'm in Shanghai factory, which is about 25 minutes from Hongqiao Airport by car. So if you come to China, we welcome you to our factory. We can discuss. We can show you our workshop. We can show all these machines to you, and we can make a proposal for you according to the products you manufacture. Okay. Right now, let's come to the topic of today. Today's topic is fasteners quality guaranteed by automated sorter, automated optical inspection machine. This machine has the function of inspection or sorting. So the defects will be observed, will be detected. So these defective parts will be rejected, will be separated from the good ones. So as a result, these defect parts will be rejected. So they so you can collect all the good ones, all the qualified parts, and as a result, there's no risk that your defective parts may be slipped through, may be delivered to the end user. So that is the advantage of our machines. Okay. So why quality is so important for small parts, for a very tiny parts like bolts. Why the quality is so important? Because the bolts, the nuts, and the screws, these such fasteners, tiny parts, are widely used, are widely adopted in nearly all machines, in all industries, automobiles, airplanes, ships, construction, buildings, and some electronic components, and some like the construction machines. Nearly all industries will use this. The parts will be this both the tiny parts, the fasteners will be involved in nearly all industries. So you and the quantity and there may be there are maybe hundreds or even thousands of such parts used in a machine. So if any of these parts has problem, has tiny defects, it may cause big trouble. There's a case. The British Airways, the flight number is BA5390. You can Google it. You can search it on the website on the internet. The plane in the year 1990. The date is July 13th. July 30th. You can Google it. The plane is right above the Earth, maybe about 10,000 millimeters, 10,000 millimeters above the Earth in the air. Suddenly, the window screen blown off, and the pilot stepped out something out of the copy. Suddenly, so fortunately, the one engineer in the cockpit gripped the pilot. So so the pilot was not back out the plane. Otherwise, he may be uh, uh, maybe get by the engine of the airplane. So maybe cause maybe even cause serious damage or even cause the life maybe in danger. So fortunately, it's a near miss. One engineer left the pilot, and the second pilot manipulated the plane, and uh, they make an emergency descendant. So it's the air crash was avoided. There is no loss of life, but it's still a serious. It's still a serious problem. So it's a near miss. And the reason why this happened, what's the reason? After the investigation, they found that the reason is caused by the boat. Boats. The reason caused by the boats because there are 90, 90 boats used to fasten to screw the window screen, but 84 boats out of the 90 boats are undersized. In other words, 84 out of 90 boats are than required, shorter than the correct ones. Only what uh, what is the difference? In fact, these boats are only 2.5 millimeters shorter than the correct ones. Only 2.5 millimeters. It's very tiny difference. I think you cannot distinguish them by human eyes. If you do not use a measurement tools, use vernier calipers, you cannot distinguish. It's difficult to distinguish them, especially if you do not have good eyesight like me. I'm short-sighted. I'm wearing a pair of glasses, so mm, I'm not. It's difficult for us. It's difficult for me to check the appearance, to check by my eyes. So so it's a very tiny difference. It's a very small error, but it causes big trouble. Small small problems cause big trouble. So I would like to emphasize the quality of fasteners like bolts, nuts, and of course fasteners is a very wide group. It's a uh, category, very big category, and the is uh, many parts belongs to this category. Bolts, nuts, screws, washers, washers, rivets, pins. These are all belong to this class. Uh, pins. This is a pin. It's a special pin. Actually, it's uh, non-standard pins made by CNC machine. You can see it's 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 a non-standard part. It's one side at the bottom, one side is flat, but at the other side there's a hole. This is a brand hole. It's not a throw hole. It's a brand hole. And at one end of the part, there is a very tiny through hole, very tiny through hole. So it's a non-standard part. Of course, during the manufacturing process, some problems may occur, and there may be some defects on the surface, or even the dimensional maybe outside. How to observe such defects? How to measure the dimensions and make sure them within tolerance? It's very difficult to measure them by human eyes by using manual methods. So it's important. It's a wise choice to choose our optical sorting machine. To use the automated machines to guarantee the quality of fasteners, guarantee the quality of the pins. Okay, so now I would like to introduce the hero today, the main role of today of this morning's live stream. This is the live stream in Shanghai, and I'm your host, Howard. The main role of this live stream is the machine here, the automated inspection machines for pins, for these pins, these non-standard pins. Okay, to start, let me first introduce the structure of the machine. The structure of the machine. Okay. Here you can see the structure of the machine is made of two parts. The machine is made of two parts. The main body of the machine, main body, it's a chamber. We call it a chamber. Actually, the workstations are protected by this by this shell, it's like a cabinet, and you can open it and so yes, it's a cabinet, and the main parts of the machine are inside it. Beside that, there is a feeder. The second part is the feeder. It's a vibrate ball feeder. This feeder will vibrate the parts and orient them and finally convey them to the main body of the machine, to the work table of the machine. Okay. There's a linear feeder to connect like a bridge. It's a linear feeder. It will connect the vibrated ball feeder and the work table of the machine. Okay, that is the basic structure of the machine. The machine consists of two parts: the main body and the feeder. Okay, for the feeder, you can say it's like a vibrated ball shape. Somebody may ask uh, for this feeder, um, what it's very noisy. Can you reduce the noise because our operators are very sensitive to the noise. I want to make the machine to make our workshop quiet. It's a good question. Of course, we have many solutions. First, we can replace this vibrate ball feeder by another type of feeder. We call it centrifugal feeder. For centrifugal feeder, the advantage is that its noise is much less noisy. It's much quieter than the normal ball feeder. Besides that, it's the centrifugal feeder takes the advantages of a centrifugal force. So the part will not be twisted. The part may it will eliminate the risk that the part may be twisted. So that is the advantage of centrifugal feeder. And of course, it has the centrifugal feeder has the advantages, uh, has the drawback, has the disadvantages. The main disadvantage is that the speed is a little slower. The centrifugal feeder, the speed is a little slower. So it depends on you, which you would prefer. But somebody may ask, I want this high speed, I want this type of feeder, but I also want to make the noisy to eliminate the noisy. I want to not like the noisy. I want to decrease the noisy. I want to quiet workshop. In that case, we have another solution that is sound enclosure. We may envelope this feeder by a sound enclosure. It's like a cabinet. It's like a steel made of a steel sheet. It's a cabinet, and the foam are attached inside. Foam inside are placed inside the cabinet. So the noises, most of the noises will be observed by the phone. Next time I think next time I can show you the machine, the sound inclusion, which will reduce the which can reduce the noise caused by the feeder. It can reduce the noise significantly. Okay, so that is the feeder, and we have some solutions to reduce the noise. Okay, after that you can see we introduce the main body of the machine. I open the cabinet, open the chamber, and the part done by the feeder and concealed but only the inner feeder. Inner feeder is called brain, and the part the inner feeder will be concealed to the work table. The work table is made of high transmittance, high transparent glass. It's like a very big disc. We call it glass disc or glass dial. It's the work table of the machine. The card stand on the glass dial. The card stand on the glass dial. Then stand on the glass dial. Then there will be initiative by the machine. First, there is the mechanism is with one steel wheel at the bottom. The steel wheel is bound the dumbbell. It's only a few millimeters above the dumbbell. There's no touch. The steel does not touch the dumbbell. There's a very tiny clearance, very small clearance. The steel wheel will rotate at the same speed, of the dumbbell. So the part will be pushed to the right position, will be adjusted to the correct position, to the correct track on the dumbbell. Then we come to the first, another mechanism, the sensor. The sensor attaches to the mechanism. So sensor will generate a red light itself as itself as itself as reflecting, or you may call it a lookout. The sensor will tell the system. The sensor will generate a signal and tell the system that is a part is passing, is coming. Please get ready for inspect. Please get ready for inspection. Okay, so the system knows that a part is coming, and it can also count the number. So system know, so the machine know how many parts have conveyed to the work table. Okay. After that, we come to the first workstation for inspection. Here's your mark, PCB1. This workstation is used to inspect the bottom, the quality of the part. The camera is placed at the bottom of the uh, is placed below underneath the glass door. So it will get the bottom view. So it will get the bottom image view of the part. Here it's a flat bottom. And then that surface are placed both on the top and underneath the glass door, underneath the part. So it will manifest the image. Okay, the first you will check the quality on the bottom. Maybe there's a rust on the bottom surface. Maybe there's a scratch. There's material, some material cut uh, by lack of material. Such problem will be observed by the first workstation. After that, we come to the second workstation for inspection. There is CCTV2. The camera is placed at a corner inside the chamber. So it will give from one side of the table. It will give the side view. This is the side view. Uh, so it will measure the length or the height of the part of the part of the part. And it will also measure it, and it will um, uh, check whether the height is within the tolerance or not. After that, we'll come to the third station for inspection. Here you can see the camera and the lenses is quite unique. It's like a trumpet or like a horn. Uh, this one is quite unique because they can get 8 images, sorry, 80 images from 8 directions, from north, from south, east, west, northwest, northeast, and southeast, southwest, 8 directions, and get 8 images. So uh, the entire contour of the path will be observed, will be detected. There's no dark corners. There's no hidden areas. So the path, the surface quality will be inspected thoroughly by this third workstation. We call it 300, 360 degrees contour inspection. Okay, after this workstation, we are collecting the parts according to their quality. First, we are the good one. If there is no imperfections, there's no defects found on the surface of the part, and the dimensions are within the tolerance. These parts will be judged as good ones and corrected by the first bin. First bin, good ones. The first bin will be brought off to the first discharge port. And after that, we come to the next discharge port. Here you can see there's a orange tube. Tube. So it will bring off this discharge. If there is defects on the surface, if they break, if the dimensions are outside, not within the specification, such parts will be judged as defective ones and will be brought to the second discharge port. So you can see the second orange tube. The high pressure air will blow off the parts. Okay, now we come to the third discharge port. besides good ones and the bad ones. Somebody may ask why we need a third discharge port. Besides good ones and bad ones, the answer is that there sometimes there may be some emergency. Some emergency happened and the emergency button here the emergency button are pushed suddenly. So the machine are power off suddenly, unexpectedly. In that case, we are not certain whether the parts remain on the glass dial is good or bad. The quality of these parts are uncertain. So in that case, we are restart the machine and the parts remain on the glass dial will be just as uncertain and they will be collected by the third discharge port retest, collected by the retest correct beam. Okay, this parts then will be collected and poured in the vibrable feeder and to be retested, to be tested, to be tested, to be inspected once again. That's why we need a third discharge port. So the parts will can be separated, can be sorted by our machine with by three categories. First, good ones. The second, defective empty ones. The third, retested ones. Okay. And for these good ones, we can also add more mechanism to the good ones, to the discharge port of the good ones. We may add automated packing mechanism. We can pack them by small small boxes, maybe 100 pieces or 200 pieces per box. For the defective ones, they can be collected by our by the quality department, and the manufacturer, the fastener manufacturer can analyze the part and try to improve the quality in future. Okay, so that is the structure of our machine. So uh, hi guys, welcome to our live stream. This is Howard with Open Next Group. I'm your host today, and right now I'm introducing the structure of our machine. So now I will run the machine and let the machine tell. As the proverb says, seeing is believing. Please follow me. I will power on the machine. It's very user friendly. Okay. Just push that down and then you can start to work. Here you can see the vibrant band feeder. It will oriented. It will vibrate the part and they can be unveiled to the work table. And the selection of parts all the steps. The hole, the ground hole will be on the top, and the flat surface will on the bottom, and they will rotate it together with the ground shell, and they will be pushed to the correct track, to the correct on the ground by the mechanism, by the first mechanism with steel wheel at the bottom. And the second element is the sensor. It will generate a signal when the part is coming. So it will tell the system that a part is coming. Please get ready to inspect. And the first inspection of station will shift from bottom. It will get the bottom wheel. And the first and the second workstation is called the side wheel. You will get the side wheel with the part. You will check the quality, the height, or the length, or the height, or the length of the beam. Whether they are the height is within the current or not. And the third workstation is called So if there are any effects on the surface, those parts will be rejected. They will be observed and rejected. Okay. After that, this part will be separated according to their quality. The first is blue eyes. They will be brought by the electron mechanism. They will be brought to the first discharge port and created by the first gravity. After that, the second discharge port, they will be brought to the second discharge port. The first one, the dimensions or the appearance, the dimensions are outside or the appearance are not good. This part will be just as ND1. And the third one is the test discharge port. The pass the emergency, the power of shut on suddenly. This pass will be just the pass remain on the gas cell will be just as detected and will be come through, will be brought to the test discharge port and corrected by the test again. That uh, as the structure of the machine. Three workstations and three discharge ports. Of course, we can, according to your requirement, we can add more workstations to the machine. We can add more workstations to the machine. One of our machine has 9 workstations, so it can insert many items. It can check measure a lot of dimensions and check a lot of check many uh, visual defects. And the discharge port, we can also add a discharge port. We can separate them by more groups, than three. Separate the defect ones, we may separate them further. Uh, Maybe dimensional outside part. Uh, Maybe the defect part with the outside dimension be corrected by one correct beam, and there is some visual defect created by another beam. We can defect them. We can separate them according to your requirement. Okay, that is the structure and the running of our machine. Now, somebody may ask whether our parts can be made by your machine or not. Would you make or break the production? Okay, no problem. Here I would like to introduce some typical parts which can be inspected, which can be sorted by our machine. First group is bolts. Bolts, it's a large group. Bolts like hex bolts, French bolts, carriage bolts, and the stove bolts. Some stainless, some headless bolts, we call it studs or set screws. Okay, and all kinds of bolts made of different materials, carbon steel, stainless steel, uh, copper, brass, aluminum, maybe different kind of material and different finish, surface finish like hot dip, galvanized, or zinc plating, uh, nickel plating, tin plating, uh, and black oxide coating, cyclomate, and uh, some other uh, plating, electro plating, and so on. This one is a boat with made of carbon steel, and the surface is uh, aluminum. Or sorry, the surface is zinc plating. The finish is zinc plating, and the socket and the head is socketed with with a socket which will accept Allen key. Allen key will This is a boat with the hex head and a flanged boat. This is a boat made of pure copper, and also there is a hex shape hex shape branch. Okay, both both these are both. Another group is nuts. All types of nuts, hex nuts, square nuts, peanuts, peanuts with broad, 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 broad peanuts, rivet nuts, and nerd nuts, nerd nuts, wing nuts, salty nuts, coupling nuts. Okay, this one is a hex nut with hex nut made of carbon steel. The surface is also zinc plating. This is a peanuts. Peanuts. This is a rivet nuts. Rivet nuts, carbon steel, and with color zinc plating. The hole, you can see, it's a rivet nut with a half hex here, half hex, and a flange here. Actually, the machine for the inspection of this part is under development, and it's placed at one corner of our factory. I think I can introduce it to you next time. Okay. Rivet nut with half hex, and the coating, the surface is galvanized, carbon plating. This is a nerd nut. It's made of brass. Brass is an alloy made of copper and zinc. Node nut, the cylindrical surface are node, so it will increase the friction. It can be screwed and unscrewed by human fingers. Besides that, another group is screws. Screws, self-tapping screws, self-pointed, self-drilling screws, nose screws, pocket screws, timber screws, drywall screws, concrete screws, metal sheet screws, the wheel screws, the heavy screws, two sides are screwed, two sides with screws, with threads are two sides, door screws, okay, some heavy screws, like set screws. This one is self-tapping screw with the pointed end and branch head with the Phillips branch. Phillips branch. This is a set screw. Set screw. This one is very unique. We call it same screws. Actually, it's a combination of screws and washers. There's one screen washer and one plain washer attached, pre-attached to a machine, to a machine screw, and we call the assembly uh, SEM schools, SEMS or SEMS schools, SEMS, SEMS schools. Okay, they are a type of pre-assembled schools. It's very convenient in some circumstances because the washers and the screen washers and the plain washers are pre-attached to the machine spool. Okay, this is also screw. It's quite unique because it's quite unique. It's very long. The length of the screw is 250 millimeters. We can inspect so long screw. The surface is deformed. You can see it has a good performance in corrosion resistance. Good performance for corrosion resistance. The chromate. It's a special coating. Okay. Besides that, another group is rivet. This is a brand rivet, or you may call it self-piping rivet. The the material, the core material is steel, and the coat, the jacket is made of aluminum. For this part, they cannot they cannot stand properly, stand in a fixed position on the surface. The position on the surface on the table is random. So we developed a special machine. We adopted a special mechanism. We call it throated steel dial. It's a disc made of steel, and all around it have several small slots. The parts, the rivet can be fixed on these slots, so we can make inspection. After that, this is also a rivet. We call it a tubular rivet. It's made of, there is a hole inside in the middle. It's made of aluminum. Okay. Hi guys, welcome to our live stream. This is covered with Open Next Group. I'm your host today, and right now I'm in our Shanghai factory, which is about 25 minutes from Hongqiao Airport by car. Our factory is located in Shanghai Jiaotong University High Tech Park. We are a certified high tech enterprise, and we have a strong R&D team with many experienced engineers, software, optical engineers, software engineers, and mechanical engineers, and electronic engineers. We combine the hardware and the software and provide you a full solution to improve the quality, to guarantee the quality of the fasteners. So if you have any questions, just comment down here, and I will give you a reply right now. I will reply you instantly. Another group of machine handset is pins. This is a door pin or hinge pin. Other pins like copper pins, yes, copper pins, ring pins, nearly all kinds of pins. Another group is this washer. This is a flat washer, fender washer, spring washer, lock washer, split ring lock washer, uh, internal ring tooth lock washer, internal tooth lock washer, external tooth lock washer, and the sealing washer. Sealing washers are special washers with one side steel and the other side rubber. Okay, this is a flat washer. It's made of carbon steel and the surface is zinc plating. This is a Brazilian rock washer. And see, there's the opening. There's the opening here. It's a helix Brazilian rock washer. The helix rock spring washer. It's made of a carbon steel, and the core surface is color zinc plated. Another part is this. It's a cover. It's a shallow bowl-shaped cover used in automobiles. For this part, the machine is quite unique because our machines, one set of our machines can inspect 19 different sizes of this part. 19 different sizes. There are three. 19 different sizes, very big one, small one, by inspected by one machine. Another, this is also some part. The shape is quite unique. We call it irregular shaped stamp part. For irregular shaped stamp part, the problem is that whether they can be fed automatically. Some feeder may cannot work properly. So you can send us some samples and we will make a proposal for you. We'll tell you whether they can be inspected automatically or not. This one, no problem. This one we can inspect them automatically. Carbon steel and surface is then plating. Okay. Retaining ring. This is uh, internal retaining ring. Use the together with the shaft and some other parts for externally retaining ring. Used together with the hose. Both can be inspected by machine. Another group is this bearing or ball bearing. Roller bearing, needle bearing, angular contact ball bearing, or can be measured instead by us. For ball bearings, the problem is that the structure is complicated. It's a combination of several small parts. The outer wrist is the inner wrist, the retainer or the cage, and the rolling element, the small round box. So many parts. So there's many items should be inspected. It's very difficult to check them by human eyes. To check the quality using manual methods, especially especially very small, especially very small ones like this. Very difficult to observe to check the defects by human eyes because they're very small. They can be put on our rivet, very small. For very small for bearings like this, we developed one machine with non-workstation, and we embedded the AI deep learning algorithm. Non-workstation, and we can check 20 items, 20 different kinds of inspection items. The outer diameter, the inner diameter, the rust on the surface, the scratch, the burn, the dent, and the smudge, and the deformation of the retainer, the dent on the surface of the retainer, and the bolts missing. Maybe one or two bolts may miss. The missing of bolts. All these defects can be observed and be measured by us. Okay. And we embedded the AI deep learning algorithm, and we eliminate misjudgment. We can make sure zero misjudgment, and there's no risk that the defect path may slip through and deliver to the end for bearing. Okay, other parts like plastic parts like this, plastic bush, like a bush. plastic rings, rubber O-rings. This can also be made by inspected by us. Let's do wood pin. The cylindrical surface are not. It's a wood pin. And besides that, ferrous core made of ferrous. It's magnet. It's a kind of magnetical material. Ferrous, ferrous, ferrous core, magnet, silicon steel core, and some electronic components like this one. Very tiny SAMA dioxide. It's a special electronic component. They can be also be made by our machine. Okay, so that's the typical that some typical parts which can be inspected by our machine. Okay, welcome to our lab stream. If you have any question, please just comment down here. I have just introduced the structure of our machine, the running of our machine, and what tasks can be inspected by our machine. Uh, Now, I would like to uh, tell you what are the dimensions and inspection items can be uh, inspected by our machine. First is dimensions, the diameters, the diameters of the head, the diameter of the shank, the major diameter of the thread, the minor diameter, the pitch diameter, and the height of the head, the total length, the dimensions can be, and the chamber dimension can be inspected as the inner and outer, outer diameters, the thickness, the distance from opposite edges, and distance from opposite angles, the height, the length of each edge. This is a barb fitting. The stage of each the stage. There are several steps. The height of each step can be measured by our machine. Can be measured in one workstation simultaneously. The total length of the rivet, the diameter of the core, the diameter of the jacket, the diameter of the pin, the height, critical dimensions of this irregular sample part. Okay, so you can see we can measure nearly all the critical dimensions of a part of a product. Okay, so that the geometrical currents are very important, such as straightening. It's very easy for sonar parts to be deformed. So the straightening will guarantee the straightness of the part. The roundness of the hole inside the roundness, the concentricity of the inner hole and the outer hole, the concentricity, the height, the initial height of the opening, initial height, the diameter, the concentricity of the holes. consider of the holes and the outer diameter, outer circle. Okay, geometrical torrences are also be inspected by our machine. The brightness, the complexity, the roundness, the straightness, the perpendicularity, perpendicularity. Okay, another group is the stamped letters. Our machine has the OCR function, optical character recognition function. We can recognize, we can observe the stamped letters on the surface. The part number stamped on the cage of the variant. The stamped letters are the head of the boat. The stamped letters indicate the grade of the boat, so we can measure them. We can detect the character and sort them and separate them according to the grade. So in same size, same appearance, both are mixed in the different. They have a different grade. We can separate them according to their grade based on the knowledge of OCR, optical character recognition, OCR function. Another group is the appearance defect or visual defect, the damage of the thread, the gouges, the discontinuity, the discontinuity, the discontinuity of the thread, and uh, the crack at the head, the crack on the surface, the dent on the surface. This appearance defect, the rust on the surface of the very tiny ball bearing. They burn at the edge. The part is the washer is stamped in a smash is stamped. So the for one side is sharp, the other side is bent. On this side, there may be some burn. Such defects, no problem, can be inspected by our machine. Uh, the plating is color then plating. The plating defective can be also observed by us. The coating, this is the chromate. The chromate is a special coating. The coating problems, the coating quality defective may also be observed by us. There is a hole. It's a brand hole. If the hole is brand is blocked, is blocked. In that case, it's also that blocked. The crack, the damage of the internal thread. You can see the for nuts, the threads are inside, so the internal thread is difficult to observe inside. But we have special lenses and cameras. We can get the 360 degrees, the entire internal thread. So we can get the image by one shot. So that we can observe, we can get them by one image. Special lenses and camera. You can also count the number of the turns. Maybe there are one turn, two turns, but the customer, the manufacturer wants a standard number of turns. We can check the turns. We can count the turns number. Okay, so that's some typical typical real defect can be observed by our machine. If you are a center, if you are doubt whether a defect you want to observe, you want to inspect it, whether a defect can be observed, can be detected by our machine. Please send me the symbols, and we'll make a proposal for it ready. We'll tell you whether we can tell you whether we can make automated inspection or not. And if yes, what is the speed? What is the speed we can achieve? Okay, so if you have any questions, just come down here. Welcome to our live stream. Welcome. This is Howard, your host today. Right now, I'm in your Shanghai factory. I'm the salesman of OpenNet Group. OpenNet Group is a group company with many branches all over China. And our Shanghai branch is mainly focused on the research and the development and the manufacturing of inspection machines, of especially and other intelligent equipment. We make intelligent equipment for the inspection, for the sorting of fasteners, that bolts, nuts, screws, rivets, and washers, bearings, ball bearings, yes, and stamped cards, regular stamped cards, electronic components, uh, yes, and magnetic parts, magnetic cores. We can inspect nearly all kinds of parts in small size, in large volume. Small size parts in large volume. Our machines are very suitable for the inspection of that machine, for that part. And the machine below me is one of our cutting machines. This machine is used for the inspection of food, sorry, pins like this. It's a irregular machine pin made of CNC machine center. Okay, this is our machine for the inspection of for the inspection of for the inspection of the non-standard pins. That's right. Okay, so our live stream is well advanced, 21 hours. So please make a conclusion. Please allow me to make a conclusion for live stream. The advantage, I would like to emphasize the advantage of our machine. First, accuracy. We can achieve accuracy up to 0.01 millimeters. That is 1% of 1 millimeter. And we adopted based on the machine technology, machine vision technology, we can achieve non-contact, non-destructive inspection. So there is no risk that the part may be damaged during the inspection process. There is no risk that the part may be scratched, may be damaged during the process. Okay, the second advantage is efficiency. The speed we can achieve is 1,000 pieces per minute or even higher. Of course, the speed depends on the size, on the structure of the part. But usually we can achieve at least a few hundred pieces per minute, or may achieve the speed of 10,000 pieces per hour is no challenge for us. For small parts, for big parts, maybe the speed is a little slower, like this one. The speed in the speed we can the machine is about 60 pieces a minute. Usually, but for this house, the production speed is also lower. So, in most cases, our inspection machine will not become the bottleneck of the procedure. Uh, After building, there's there's a pitch, and one one of our customers purchased one set of our machine, and the result is that it saved 5 to 6 operators, and the labor cost of 5 to 6 operators in 1 year is about 2 times the price of one set of one machine. In other words, they recover their cost within half a year. Within half a year, the ROI is only 6 months or even shorter. Okay, that is the efficiency. The third advantage is consistency. Our machine makes judgments based on the user's defined accept and reject criteria. So once the criteria is set, once the criteria is defined, the machine will make the same judgment again and again. For defect parts, it will judge it 100 times and the result. For standard defect parts, the machine will make judgment 100 times and the result is always the same. But for operators, for manual methods, the operators make judgment subjective and inconsistent. They may judge it as good one this time, they may judge it next time bad one. So there's no guarantee of 100% good quality using manual method. Okay, so that is the advantage of our machine consistency. Besides that, we have uh, uh, or we have a strong software team. We can embed it. We develop AI deep learning algorithm, and with the AI deep learning algorithm, we can achieve zero misjudgment. We can eliminate the misjudgment. There's no risk that the defect part may be judged as good one and shipped shipped to the and delivered to the end user. There's no risk there's no risk of misjudgment. Somebody may ask, how do you achieve zero misjudgment? The answer is that how you achieve how the function, how the principle of the AI deep learning algorithm. The answer is that first we collected it, and we have made a lot of experience in this area. We collected many pictures and marking these pictures, marking the defective areas, and we use these pictures to train our machine, to train the system. So after this training, the system will know how to make correct judgment, and then will verify the system, the machine judgment. Will verify them, and will make sure they always make the correct judgment. And finally, the machine can make correct judgment itself. That is AI deep learning algorithm. Hi, welcome to our friend. This is Juan, your host today. I'm the salesperson. I'm the salesman of Overnet Group. Overnet Group is a group company with many branches all over China, and I'm based in Shanghai. Our Shanghai branch mainly focuses on the development, and research and development and manufacturing of automated inspection machines for fasteners for more parts, yes, and other intelligent equipment. So So if you have any questions, just comment down here below. Okay? The machine below me is material or typical or material sorting, sorting, sorting machine, which can inspect the quality of very special or special pin, special non-standard pin. It's a special pin with one bad hole at one side and a very tiny straw hole at one end. Okay, so our machines are always customized. So if I have a question without whether your part can be inspected by us or not, just send me the samples and we'll make a proposal for you ready. We'll tell you the speed we can achieve and how many workstations we need and the configurations of each workstation. We'll tell you all these technical details. Um, so that is our live stream today. And our advantages is accuracy, efficiency, and consistency. Welcome and have a nice day. This end today's live stream. Have a good day. All right. See you next time.